All right, guys. So when I recorded this morning, for some reason, the recording never showed up in my Google Drive. So we'll just do this over again real quick. So first of all, this problem, which of these relations is a function? So we're going to use the vertical line test. In other words, we're going to take a vertical line and see if it touches 2 points. Yes. And so A is not a function. But with B, it passes. And you see here, C fails and D fails. So by the vertical line test, I can say that B is a function here. For problem 2, given f of x equals x squared plus 2x, find f of a minus 3. So f of a minus 3 equals, yes, sir.
Sorry.
That's okay. What you need?
We just seen another link.
Uh-huh.
Show me how to bypass it.
Oh, okay,
There's
cool.
a spot on, if you right click and go shareable drive,
Uh-huh.
you can change it to no restrictions.
I need to do that.
Yeah.
Hey,
I
thank
sent
you.
you another invite, let me know if it works.
Okay, sure, buddy. Okay. All right, so a minus 3 squared plus 2 times a minus 3. So that's a squared minus 6x plus 9 plus 2a minus 6. Using the shortcut here, a minus b squared is a squared minus 2ab plus b squared. So that's how I got this bit. And then distribute the 2 to get this bit. Now let's combine like terms. So a squared, and also, why I wrote x there, that should be an a. There we go. So minus 6a plus 2a is minus 4a, plus 9 minus 6 is plus 3. So this is a squared minus 4a plus 3, f as in foxtrot. Problem 3, find the zeros of this function. When we want to find the zeros of a function, we're going to set f of x equal to 0, and then we're going to see what x's make that true. Because this is a quadratic, there's 4 strategies we could employ. We could graph, we could factor and use the zero product property. We could complete the square, or we could use the quadratic formula. I'm going to factor and use the zero product property here. So I need 2 numbers that add up to -3 and have a product of -108. So that's going to be x minus 12 and x plus 9. So zero product property. I set both of those factors equal to 0, and I get x equals 12 or x equals -9, which corresponds to A as in alpha. Problem 4 here. So we want to find f of -8 for the following. So let's see here, f of -8. So this is a piecewise function. Notice -8 is in this upper domain portion. So the relevant domain is this x less than -2, because -8 is less than -2. So we got to use this. So in other words, it's going to be -4 times the absolute value of -8 plus 3. So -4 times the absolute value of -5, -4 times +5, or -20. G is in golf. Problem 5. To what is the graph of an even function symmetric? That's a definition question. Should be the y-axis. Don't miss that one. If the graph of a function is symmetric about the origin, which means it's odd, which of the following must be true? You remember the algebraic definition for oddness was f of -x equals -f of x, which is G is in golf here. So again, a definition question. Don't miss that one. Moving on to number 7. So which function has a jump discontinuity? So this problem could be really hard, or it could be really easy. Really hard if you go through and start looking at these discontinuities. Really easy if, once again, you remember the definition of the jump discontinuity is that it can only occur in piecewise functions. Well, how many piecewise functions do we have here? One and only one. And so it must be A without any calculation whatsoever. I know the jump discontinuity can only occur in A. Problem 8, for g of x equals 2x over x squared plus 1, what expression for A makes the limit of g of x as x goes to A equals A correct? In other words, What does it go to as x goes to infinity? Well, if we look at this, we're going to see to the right, it's going to get lower and lower and lower and lower. In other words, closer and closer to 0. So the limit as x goes to infinity of g of x, in this case, is 0. And that's a graphical problem. If you punch it in the calculator, it would be obvious. Let me share the whole screen here so you can see my calculator. All right, so if I punch in 2x divided by x squared plus 1 and hit graph, we'll see this is approaching 0 as we go out to the right. So if I were to do the table set up in here and go to 100 and go up by hundreds, let's say, I'm seeing that number get smaller and smaller and smaller. In other words, it is approaching 0. So that's why G is in golf is the correct answer here. Moving on to problem 9. Emiko will make a box without a top by cutting out corners of equal size from a sheet of cardboard. So this is a problem like the one we did, and I warned you that you'd see it again. So the small dimension is 15, the large is 28. We're cutting out X-shaped or X-sided squares from each corner. And we want to know the maximum possible volume of this box. So remember that the volume is going to be length times width times height. And in this case, we'll set the shorter version equal to the length. So that's going to be 15 minus 2x. And then the larger dimension equal to the width, and that'll be 28 minus 2x. And then finally, the height will just be x. So that's 15 minus 2x times 28 minus 2x times x. So that's the function we want to maximize. Let's punch that in the calculator. So 15 minus 2x, 28 minus 2x, and then x will be our factors. And if I choose my window carefully here, I'm going to go from 0 to 7.5, because those are the smallest and biggest possible x's. And then let's go from 0 to, I don't know, something like 1,000. Looking at the answers, that might be a good choice. And sure enough, here we go. There's the max. So second and trace, option 4, start about 1, end about 4. And I see the max occurs where x is 3.12, but the y value, which is what we're concerned about, is 594.7. So which of these is closest? Well, 595 is closest to 594.7. Usually on pre-calculus tests, they want you to be very precise. So the fact that they just want you to pick the closest value here is a little unusual. So read your problems carefully. Problem 10. The height in feet of a flare t seconds after a shot is modeled by this equation. So we're going to find its average speed from 4 to 6 seconds. So we're going to get x sub 1 and f of x sub 1. So that's going to be 4 and f of 4. And then over here, we got x sub 2 and f of x sub 2. So in that case, it's going to be 6 and f of 6. So first of all, this is f of 4 is going to be negative 16 times 4 squared plus 104 times 4 plus 1.5. So that's negative 16 times 16 plus 416 plus 1.5. So that's negative 256 plus 416 plus 1.5. And we'll find that with the calculator here. Negative 256 plus 416 plus 1.5. So that's 161.5. So I have my first point, which is, and I'm going to shrink this stuff. So I have 4,161.5, like so. Now for this other f of 6 is going to be equal to negative 16 times 6 squared plus 104 times 6 plus 1.5. So in this case, it's negative 16 times 36 plus 624 plus 1.5. Once again, we'll use the calculator here to save ourselves some arithmetic. Negative 16 times 36 plus 624 plus 1.5 is 49.5. So once again, let me shrink this down. So I know the point is 649.5. Now this is my x1, y1. This is my x2, y2. And our last task here is to find the slope. So m equals y2 minus y1 over x2 minus x1, which in this case is 49.5 minus 161.5 over 6 minus 4. So the denominator is going to be 2, but the numerator, we'll need to calculate here. 49.5 minus 161.5 is negative 112. So that's going to be negative 56, and it's in feet per second, H as in hotel for that one. A little more intensely difficult problem there. All right, number 11 here. You have to remember how the step function works, how the greatest integer function works to get this one right. So f of negative 17.25 is negative 3 times the greatest integer of negative 17.25 minus 4.5. And so that's negative 3. And the greatest integer function here works like a grouping symbol. So this has to be evaluated before I multiply. All right, so performing this subtraction, I get negative 21.75. But again, the floor function rounds down. Now be very careful because your tendency in rounding here would be to go towards 0, but that's not what's going to happen. It's going to go down to the next lowest integer. So this becomes negative 3 times negative 22, which is positive 66. A is in alpha. Now the calculator can do this, and it makes it trivial. So I don't even like demonstrating this, but I will so that you can check your answers. If you type in math, go over to the number tab and down to the int function. That is the greatest integer function. So this would give us the same answer, 66. But make sure you understand it before you just punch it in the calculator mindlessly. All right, on to problem 12 here. So which results in this graph being expanded horizontally? Well, expanded horizontally means a fraction times the input. So which of these have a fraction times the input? F and H. So that rules out J, and that rules out G because they have a number greater than 1 multiplied by the input. Expanded vertically by a factor of 3. So that means output times 3. In both cases, that's true, so that doesn't eliminate anything. Reflected in the x-axis. So that means output times negative 1. So that has to be F. So H is disqualified, leaving F as the only possible answer. F is in Foxtrot. Moving on to number 13. So what translation's occurring here? Well, this minus 8 is going to take us right 8 units. So only C has right 8 units. I know that's the right answer. And then plus 2 takes us up 2. So right 8 units up to C as in Charlie. Which of the following represents the graph of, and here on problem 14, the absolute value of x cubed minus 1. So if I were to just graph x cubed minus 1, that's going to look like this. But if I take the absolute value of the x cubed part, do you see how the negative x's are going to behave like positive x's? And so we'll have, instead of this downward part, we'll have this. And so it's going to look like J is in Juliet. And I'll show you how to punch that in your calculator real quick, like so. I go to y equals, I can punch in math, go to the number tab, I see ABS, x cubed, and then minus 1. And my zoom is weird here. Let me hit zoom 6. And there we see a graph very much like J is in Juliet. Moving on, this is problem 15. And it says, if I have this f and this g, find f minus g of x. So this problem is going to be a little challenging because it's going to require to use some pretty dusty algebra skills maybe that you haven't used yet in this class. So that's f of x minus g of x. And that is 1 over x plus 2 minus 3x. So we've got two terms here and they do not have a common denominator. So clearly based on these answers, I need to combine these two into one single rational expression. And I'm going to do that by making them have a common denominator. So I'm going to multiply top and bottom by that denominator value. And then I have 1 over x plus 2 minus 3x squared plus 6x over x plus 2. And then distribute this negative sign to both of these terms. So that's 1 minus 3x squared minus 6x over x plus 2. And if we look up at the answers, so a positive 1, so I know it's not B. So minus 3, this has got a positive 6x, so I know it's not A. Positive 6x, so I know it's not D. Has to be C, as in Charlie. And they just rearrange the terms in descending order to get that answer. All right, so that's 15. On to 16. 16 requires you to know the volume formula for a cone. So the volume as a function of the radius of a cone. And that's easy to find on Google if you don't have it memorized. Most people wouldn't. So we're just going to type in volume of a cone. Because it's not on the test, I want to show you guys the best method for finding any exotic formula you're looking for. So here I see it is pi r squared times h over 3. So pi r squared times h over 3. And so if we read this problem, they imagine a fixed height of 15. So we know h equals 15. And he increases the radius at a rate of 6 inches per minute. So the r as a function of time is going to be 6 times t. And assume the radius is 6 inches at t equals 1. That just means you don't have to add any additional parameters here. So now I want to find, and they call this f instead of r. That's okay. We'll just follow suit. So we want to find v of f of t in this case. So that's going to be v evaluated at f of t. And so that is pi, and instead of r, I'm typing in 6t squared, and then times 15 over 3. 15 because h is equal to 15. And so that is pi times 36t squared times 5, which is 108 pi t squared, which is f as in foxtrot. That one's maybe the hardest one on the test. On to problem 17. Child's play compared to the last one. F of g of x. equals f evaluated at g of x equals f evaluated at x plus 2 equals x plus 2 squared plus 1. So that's x squared plus 4x plus 4 plus 1, which is x squared plus 4x plus 5, which is d is in delta. All right. Problem number 18 asks us to find the inverse of f of x. So f of x equals 1 over x minus 2. First task is change f of x to y. The second step is to switch all x's to y's and all y's to x's. The next step is to solve for y. Again, kind of a tricky algebraic situation here. I need to multiply both sides by that denominator, which will cancel here. And then here I can distribute to get xy minus 2x equals 1. So I need to get everything with a y on the left, which it already is, and everything without a y on the right. If I divide away the x here, I get this answer. And you'd be tempted to leave it in this format, but the way they have the answer set up, you need to do an additional bit of simplification and write this like so. So this is G is in golf. Then number 19, which function is 1-to-1? Which would pass the horizontal line test? Well, we know how absolute values are shaped and how transformation works, and B would fail. We know how the greatest integer function works and how that transformation would impact it. So that's going to be, like this, which would of course also fail the horizontal line test because those are a bunch of little horizontal lines. Now with this one, I think it's going to look something like that in the graph. So that would of course fail as well, meaning A is our only possibility. Would pass the horizontal line test, and it would look something like this, but it would pass the horizontal line test. A is in alpha. Number 20, last one. So George saves 15% of every paycheck plus $25. So his savings as a function of his paycheck amount is 0.15p plus 25. So what function can be used to find his paycheck given his savings? So in other words, we want to invert this. So let's change s of p to y, and we'll change the variable here to x, just so it's the same as the other problems we've worked. Now we make every x y and every y an x, and we'll solve the resulting equation. So I'm going to subtract 25 from each side to get this, divide away 0.15 to get this expression, and that of course corresponds to H is in hotel. All right, so that's the study guide. Good luck on your test.